Hello everybody, this is Amarnath, Faculty of Mathematics, Assistant Professor in Department of Science and Humanities, MLR Institute of Technology. Today I am continuing the lecture in the subject Matrices and Calculus, continuation of the rank of a matrix, that too specially in echelon form, how to find the rank of a matrix. In the previous lecture we have done rank of a matrix definition, the number of linearly independent eigenvectors, definition and properties. What is the rank of a property? Null matrix property, rank, identity matrix, rank of the matrix. What could be the high maximum rank of a matrix if a M cross N matrix is there? Such type of properties we have discussed very clearly. Using minors, how to find the rank, that all we discussed. In today's present lecture, we are going to learn what are the elementary transformations of a matrix. What do you mean by echelon form? And how to find the rank using echelon form. These topics we discuss, and some of the problems also we discuss. Right? Now, before going to the echelon form, we need to discuss about elementary transformations or operations on a matrix. Which type of operations we can apply? That is, basically we have three defined operations are there. That is, first one, interchange of rows and columns. Okay. Two rows we can interchange. In place of one row, another row. In that place, the given row. That is indicated by R1. Suppose I want to interchange R1 and R2. So you can write R1 double implies R2. In place of R2, R1 we can write. In place of R1 we can write R2. Depends on the requirement. Similarly, we can do for columns also. C2 double implies C3. Means you can interchange two columns also. Whenever you required, you can interchange columns also. This is the first basic operation. Interchange of rows or columns are allowed. Next, second one. Multiplication of each element of a row or column with a non-zero scalar. Suppose you want to multiply R2 row, you want to multiply with 3R1. Yes, you can do. Or suppose R3, you want to multiply by 1 by 2. 1 by 2 of R3. Yes, you can do. But it should be non-zero row. Non-zero element, it should be multiplied. R3 into 0. So it is not accepted. R3 into 0 R3. It cannot be applied. It is a wrong operation. Okay. Non-zero scalar you can multiply. Next, multiplying every element of a row or column with a non-zero scalar, above step, and we can add to the corresponding elements of other row or column. Right. So look and see. Suppose R2 can be multiplied by some scalar, non-zero scalar 2R3, and it can be 2R2. It can be multiplied to some other element, that is some other row R3. So R2 is multiplied by 2 and added to the corresponding elements of R3 we can do. Similarly for columns also. Suppose C1 is multiplied by 3C1 minus C2. Addition or subtraction can be done. So it can be columns or it can be for rows. So these three elementary operations can be allowed while finding the rank of a matrix. Determinant row and column operations are different. Here these elementary transformations are different. While finding echelon form and normal form, we can use only these three operations. One is interchange of the rows or columns, or multiplying any row or any column with a non-zero scalar, and third one, after multiplying you can add or subtract to the corresponding elements of the any other row or column. These three operations are allowed. Right? Next, what do you mean by the echelon form? First we learn how to find a rank using echelon form and normal form. Both are there. First we discuss echelon form. So here, look at the example. From the example I will explain how could be the echelon form. A matrix is said to be in echelon form. Look at this matrix. Here I am writing a matrix 1, 2, 3, 0, 0, 1, 4, 2, 0, 0, minus 1, 3, 0, 0, 0, 5, and 0, 0, 0, 0. Right? Look at this matrix. When can I say a matrix is said to be an echelon form? So look at the first property, 0 rows. Suppose in any matrix 0 rows are there. If it is there, sometimes in a matrix 0 row may exist, 0 row may not exist. If they are existing, then it should be below the non-zero row. So here, see, here 0 row is there, that is below the non-zero. These 4 are non-zero rows. What do you mean by non-zero row? At least one element should be non-zero in the row. Non-zero row. It is a 0 row. Last row is a 0 row. Why, sir? Because the complete elements in the 1, 2, 3, 4, fifth row, that all elements are 0, 0 row. So if 0 rows are existing, that should be below the non-zero row like this. Suppose in the middle is there, you can interchange and keep it at the bottom of the matrix. The first non-zero entry in each non-zero row should be 1. So look at this one, first non-zero entry 1, 1. Here it is a minus 1. Here it is a 5. So it can be 1 or it cannot be 1. It is a optional condition. You can maintain, or if even you don't maintain also, the rank of a matrix will not get changed. So maximum try to maintain the first non-zero entry will be 1, should be 1. Next, the very important one is third property. So which can decide the rank of a matrix. The number of zeros before the first non-zero element in a row is less than the number of such zeros in the next row. Look at this one. Here, how many zeros are there before the first non-zero entry is the second row? 1 0. Next here in the third row, 2. Fourth row, 3. This one will be 4. See, number of zeros before the first non-zero entry. So look at here I am writing how could be 1 0. So like this, 2 zeros and 3 zeros and 4 zeros. Like that, number of zeros should increase by row wise. Then the matrix is said to be in echelon form. Suppose equal are there, then it is not in the echelon form. Look at this one. Suppose here I am writing a matrix where 1, 2, 3, 0, 0, 2, 0, 0, 3. Look at this one here. This matrix, it is not in echelon form. How can we say it is not in echelon form? Here 2 zeros, here 2 zeros. Not in echelon form. You must be able to make this element also 0, then it will become echelon form. So it is in not echelon form. What is the condition fails here? Number of zeros. Here 2 zeros, here 2 zeros. Second row and third row. Number of zeros are not increasing. So third condition failed. So it is not in echelon form. Definitely it has to satisfy the third condition. Second condition is optional. Even you don't satisfy the second condition, we can say it is in echelon form. Right? So once it is in the echelon form, then we can decide the rank of the matrix. What is the rank of the matrix? Already we discussed number of linearly independent rows. So here with 0 rows if you are removing, then automatically number of non-zero rows will become the rank of the matrix. 1, 2, 3, 4. That is in echelon form. The first example matrix is in echelon form. The number of non-zero rows for this matrix, the number of non-zero rows are 4. That is rank is 4. Number of non-zero rows. Non-zero rows. Okay, that is a echelon form. Then how to convert the given matrix in echelon form? That is, we can apply only row transformation. In order to convert the given matrix to echelon form, we can apply only row operation. Column operations are not allowed. Interchange, multiply by some number, or add or subtract to some other row corresponding element. These three we can do. So far we discussed the elementary operations. Generally, I will tell you a brief method how to reduce the given matrix to echelon form. See, take the first diagonal element or first row, first non-zero entry. That should be non-zero. If 0 is there, try to get non-zero elements. And with that element, make below element 0 using row operation. Only row operation. Right? And coming to the second row, second element, make the below element 0. And come to third row, third element, make below element 0. And fourth row, below element 0. Using row operations. That is the first, the pivoting element. Using that element, it should be non-zero. 0 means interchange and get the non-zero. Make the below element 0. Come to second row and make the below element 0 using row operation. Come to third row, third element 0. Suppose that also 0, you go to next element. Suppose third row, third element is 0. Next, go to third row, fourth element. That also can be done. But try to make below element 0. So that automatically the number of zeros will increase and it will come to echelon form. And remember, in case of 0 rows, number of zeros cannot be increased. See, look at this one in the previous example 1. Look at this one here. Here, suppose here we have 0, 0, 0. 2 non-zero, 2 0 rows are there. Then here number of zeros are not increased. It is not possible because there is no other element existing here. So both rows contain 4 elements, 4 zeros. We don't have further option to increase the zeros. Right? Only non-zero rows it will increase. Right? 0 rows, number of zeros will not increase. So in the echelon form, what to be remembered? The key point is only we can apply only row operations. Only row operations. Right? And second one, the number of non-zero rows will become a rank of the matrix. Number of non-zero rows. Non-zero rows will become rank of the matrix. So now let us discuss some problems on this one. Finding rank using echelon form. Look at the problem. Here is one matrix is given. Which order matrix? It is a 4 by 4 matrix. So means maximum rank can be 4. Already we discussed in the last class. The highest minor what we get is 4. So rank cannot exceed more than 4. So we can get maximum rank of 4, but it can be 4, 3, 2, 1. That we have to do. So he's asking using echelon form. Find the rank of the matrix. So as the R ladder discussed that one, we're using R first row, first element, make below 3 elements 0. So already I clearly mentioned using first row. If it is 0, we will interchange. So non-zero 1. So using below elements, we will make below 3 elements 0 or 4 elements. How many elements are existing? That all elements make it 0. Applying only row operations. So applying only row operations. So it is a very, very important. Some students used to do column operation in the echelon form. That is wrong. In normal form, we can do both row and column. It is echelon form only row operation. So using 1, we have to make 2 0. At this one, you have to make it double. So R2 is 2. So R2 is 2. R1 also should be done double. So R2 implies R2 minus 2R1. Okay. In single step, all 3 we have to make it 0. Next, R3 element. What is R3 element? 3. So R1 also should be done 3. Multiply by 3. R3 implies R3 minus 3R1. R4 implies R4 minus 6R1. Why? Because see, look at this one. 1, 2, 3, 6, 2. 2 into 1, 2, 0. 3 into 1, 3, 0. 6 into 1, 6. 6 minus 6, 0. Just multiply with the respective elements. Right? So that we can make it 0. Look at this one. So let me apply this operation. Obtained matrix is called equivalent matrix we call. The properties will not get changed. Equivalent. So instead of equal, I am writing equivalent. So first row we are not applying any operations. So that is 1, 2, 3, 0. Second row, what we are applying? R2 minus 2R1. R2 element is 2. Above element is 1. 2 into 1, 2. 2 minus 2, 0. Next, second element, 4. 4 minus 2 into 2, 4. 4 minus 4, 0. Third element, 3. If you don't get, you write like this, for 3. Minus 2 into R1. 2 into 3, 6. 3 minus 6. That is minus 3. Next, fourth element, 2. Minus 2 into 0, 0. 2 minus 0, 2. You can write some rough work in order to get this one. Next, R3 minus 3R1. So R3, 3 element, above R1 is 1. 1 into 3, 3. 3 minus 3, 0. Next, second element, R3, 2 minus 3 to the 6. So 2 minus, that is 6. So clearly it is a minus 4. Okay. So let me write again. So this is minus 4. Next, coming to the third element. What is the third element? R3 element 1. Minus 3 into 3, 9. So here R3 element is 1 minus 3 into 3, 9. 1 minus 9 minus 8. Next, R3 element, next element 3 minus 0. 3 minus 0, 3. Next, coming to R4 minus 6R1. 6 minus 6 into 1, 6. 6 minus 6, 0. Next, 8 minus 6 to the 12. 8 minus 12 minus 4. Next, 7 minus, look at the rough work, 7 minus 6 into 3, 18. So 7 minus 18, that is minus 11. Next, 5 minus 0, 5. After applying, see, first task is done. Using the first diagonal element, below element, we have done 0. Next, we'll come to the second row, second element, and we'll make below element 0. Right? Now, how to do this one? But second row, second element is 0. That is a pivoting element. So with the 0, we should not do operations. That's why get a non-zero element in the place of second row, second element. So first row is once completed, we should not use first row. If you use first row, this element will come down here. In the place of zeros, it will be replacing. That's why once R1 task is completed, don't touch the R1. So use only R2. But R2 here, 0 element is there. Interchange. So any row, you can interchange R3 or you can interchange R4 with R2. So here I am writing R2 interchange with R3. Then it is a simple operation. Interchange is a simple operation. First row no change. 1, 2, 3, 0. Second row, third row we are interchanging. So third row here 0, minus 4, minus 8, 3. Second row we are writing here 0, 0, minus 3, 2. Next here 0. Fourth row we are not doing any operation. Same as it is. Right? So this one should be again make it second row. Using second row, second element, we can make 0. Second row, second element 4. Already third row element is 0. You no need to make 0. Only fourth row R4 element we have to 0. Make it 0. R4 implies using which row? R2. So R4 minus R2. Minus 4 plus 4 will become 0. Remember, same elements are there, subtract. At the same signs are there. Opposite signs are there, I add it. Minus 4 plus 4, 0, like that. So it is minus 4, it is minus 4. So you can subtract. A is equivalent to. So here, what is the done here? What is the first row? No change. Second row we are using to make it 0. So second row also no change. 0, minus 4, minus 8, 3. Third row is already 0 element. That also we are not doing any operation. You can write as is. Only which one we are doing? Fourth row we are using. R4 minus R2. So 0 minus 0, 0. Minus 4 plus 4, 0. Minus 11 plus 8, minus 3. 5 minus 3, 2. Now, second row, take a second task completed. Now, we'll come to third row, third element. What is the third row, third element? Minus 3. Using R4. Using R3, we have to make R4 0. See, once R2 task is completed, again, you should not touch R2. So, if you touch R2, the minus 4 will replace in the below element, 0 elements, it will replace. So, that's why R1 task completed, R2 task is completed. Now, we have to use R3 only. Don't use R1 and R2. Now, what to do? Here, see, these two rows are identical. Automatically, one row will become 0. Subtraction. R4 implies R4 minus R3. Because same elements are there, subtracting automatically, it will become 0 row. Look at this one. 1, 2, 3, 0. Next, 0, 0, minus 4, minus 8, 3, 0, 0, right, let me go for the previous slide. 0, 0, minus 3, 2. Subtraction. Only R1, R2, R3, no changes. Only we are, which row operation we are doing? Fourth row we are doing. That's why R4 minus R3. 0 minus 0, 0 minus 0. 0 minus 0. Next, minus 3 plus 3. 0. 2 minus 2, 0. Right? Now, further, can we make any 0 rows as 0 rows? Yes, we can't do. Because here, if you try R3 is already, if you try to make R3 element 0, these elements will come here. R1 elements, R2 elements will come down. Again, zeros will become non-zeros. That's why further we can't make it 0. Now, let me check what is in echelon form. The main condition, third condition should be satisfied. See, number of zeros before the non-zero entry. So, here 1, here 2, here 4. So, 1 zeros, 2 zeros and 4 zeros. Right? So, number of zeros are clearly increasing. So, some students used to do below the principal diagonal elements are 0. Don't take that one. In some problems, it is becoming the problem. Right? So, maximum try to make the number of zeros to before the non-zero entry elements are increasing row wise. So, what I have given the pattern. Right? So, 1, 2, 3, 0. 0 minus 4 minus 8, 3. 0, 0 minus 3, 0, 0, 0. So, clearly rows, number of zeros are increasing row wise. So, it is in echelon form. Clearly mentioned, it is in echelon form. It is in echelon form. Once it is in echelon form, we can decide the rank. What is the rank of the matrix? Number of non-zero rows. 1, 2, 3. 3. So that you can write a conclusion also, number of non-zero rows. Right? Number of non-zero rows. So that is the rank of the matrix. So means in the matrix we have only 3 linearly independent rows are there. And one row is a dependent row. That was done made as 0. So how many non-zero rows are there? 3 are there. That is the rank of the matrix. Right? I hope you understood. We can go for the next problem. Reduce the matrix, given matrix to echelon form, hence find its rank. So same pattern. Again, it is a given 4 by 4 matrix is given, and to find the rank, maximum rank can be 4. So let me check how much will be the rank by reducing to echelon form. So here, using pivoting element R1, make below R2 element 0, R3 element 0, R4 element 0. That is the process. So similarly, I am writing R2 implies R2 plus R1. Why? Because R1 is minus 1 plus 1 0. R3 element. R3 element is 2. So that's why multiply the first row with 2. 2 R1. 2 minus 2 0. Then R4 implies R4 plus R1. Why? Because that is minus, sorry, this is a minus 1, so that it should be subtracted. Minus 1, minus 1. At minus 1, minus of minus 1 plus 1. So R4 minus R1. Same elements are there, subtract. Same signs are there. Suppose opposite are there, then add it. Same sign. Minus 2, minus 2 should be subtracted. Minus 2 plus 2 should be added. Like that. First row no change. Minus 1, minus 3, 3, minus 1. Because you are using R1. So then R1 should not be changed. That is the key point. So most of the student, which row is going to change, that also will apply. No. So which row you are using, that should not be changed. That should be constant. Now R2 plus R1. Minus 1 plus 1, 0. Right? 1 minus 3 minus 2. Minus 1 plus 3, 2. 0 minus 1 minus 1. Right? R3 minus 2R1. 2 minus 2 minus of minus. 2 plus 2, 0. Minus 5 plus 6. Minus 5 plus 6, 1. 2 minus 6. Minus 4. Minus 3 plus 2. That is minus 3 plus 2 is 1. Right? R3 minus 2R1. So once again check. 2 plus 0. Minus 5 plus 6. 1. Next 2 minus 6. Minus 4. Minus 3 plus 2. So this is a R3 minus 2R1. Minus 3 minus of minus plus 2. So minus 3 plus 2 minus 1. Right? R3 element is minus 3 here. And minus of minus plus 2 minus 1. So even one sign mistake we won't get the answer. R4 minus R1. Minus 1 minus of minus plus 1, 0. 1 plus 3, 4. 0 minus 3 minus 3. R4 minus R1. 1 minus of minus 1 plus 1, 2. Right. Now coming to the second row, second element, and make below element 0. So it is 1. R2 is 1. I have to make it double. R3 implies 2R3. So which row we have to use now? Second row we have to use. That is R2. 2R3 and 2 into 1, 2. 2 minus 2, 0. Similarly, R4. R4 element is 4. How to make R4 element 0? So R2 element we have to make it double. So R4 is 4. It is a bigger element. So opposite sign, addition. Plus 2 into the pivoting element is 2. Minus 2. 2 into R2. Okay. Now, correct enough? Check it once. 2 into minus 2 into 1, 2. Minus 2, 0. First row no change. Second row no change. So first row task is completed. We should not use the first row. Second row we have to use. Minus 1. Minus 3. 3. Minus 1. 0. Minus 2. 2. Minus 1. 2 rows are we are not doing any change. R3 we are changing. 2R3 plus R2. 0 plus 0. 0. 2R3. 2 into 1. 2. 2 minus 2. 0. 2R3. 2 into minus 4. Minus 8 plus 2. Minus 8 plus 2. Minus 6. 2R3. 2 into minus 1. Minus 2. Minus 1. Minus 3. Once again check. 2R3. 0 plus 0. 0. 1. 2 into 1. 2. Minus 2. 0. 2 into minus 4. Minus 8 plus 2. Minus 6. 2 into minus 1. Minus 2. Minus 1. Minus 3. R4 plus 2R2. 0 plus 0. 0. Next row. 4 minus 4. 0. R4 minus 3. 2 into 2. 4. Minus 3 plus 4. That is 1. Next. R4. 2 minus 2. 2 into minus 1. Minus 2. 2 minus 2. 0. See? Check it. Is it in echelon form? No. How, sir? There's 2 zeros. 2 zeros. Same. 1 0, 2 0. So number of zeros should increase. This also should be done 0. As per our procedure, using R3, we have to make R4 0. Now R1 task completed, again don't use R1. R2 task completed, don't use R2. This, I said one pattern for you. The pattern is diagonal element, make below element 0. And here, this type of pattern. First task, pattern completed, second pattern. Now coming to the third, this one. Third row, we have to make R4 0. So make it 6 times. R4, make it 6 times. 6 R4 plus R3. Then A is equivalent to first row no change, second row no change, Third row, no change. We are using third row. No change. Fourth row. So 6 or 4. 0 plus 0, 0. 0 plus 0, 0. 6 or 4. 6 into 1, minus 6. 6 minus 6, 0. 6 or 4. 6 into 0, 0. Plus R3 and a minus 3. 0 minus 3, minus 3. Some student, they will do this one as 0. No. See, here 6 R4 is 0, minus R3. 0 minus 3, minus 3. Now, let me check. Can we do further this element 0? If you try to make this last element 0, these all above elements will come down here. So further we can't make any row 0. So is it in echelon form? Let's check. Here 1 zeros, here 2 zeros, and here 3 zeros. Number of zeros clearly increasing. So it is in echelon form. So rank of the matrix is number of non-zero rows 1, 2, 3, 4. So 4 is the rank of the matrix. Right? Number of non-zero rows. So this is echelon form. So for the practice, here I gave 2 problems. Rank is also mentioned. The students are advised to practice and check the rank. So in this session, we have discussed the elementary transformations, echelon form, and how to find the rank using echelon form. In the next class, we discuss about the normal form, how to find the rank of a matrix. So thank you.